us today. I'm really happy to have Greg Walker here with me, who has a lot of things to tell about blockchains and Bitcoin and all the cryptocurrency things that you always wanted to know and that I don't know either. So I'm really excited to learn more about this as well. Greg will talk a little bit about how you would model, import, and then use Bitcoin data or blockchain data in a graph database like Neo4j. So imagine the whole blockchain with all the transactions and all the payments and money transfers, forming a gigantic graph and importing it into a graph database and then seeing what out of that. So around five parts of his presentation, talking a little bit about his background. Decided he built learnmeabitcoin.com and then explain some of the basics of Bitcoin and blockchains and how this all works and how it goes together. And then, I mean, represent kind of how would I represent this data as a graph? How would I import it into Neo4j? What are the challenges that he ran into? And then we look at the visualizations that he has on learnmeabitcoin.com, I think, as a small demo, and then talk a little bit about some interesting queries that we can. And so without further ado, I stop sharing my screen and let Greg take over. And Greg, and take it on from here.
Right, okay. Oh, sorry. I'm sharing my screen a minute. There we go.
Yeah.
Right, is that working now? Okay. Right. My name is Greg. I've been making websites since I was about 18. And a few years ago, I found Bitcoin. And I thought it'd be interesting to try and explain how it works. So I started by making this website called Learn Me a Bitcoin, which basically just has lots of simple articles and guides explaining how Bitcoin works in really simple terms. I was doing that for about a year, about a year. And after a while, I started to feel like that I couldn't explain everything I wanted to about how Bitcoin worked through articles and diagrams alone. I thought it'd be easier to explain how it works by actually showing the data, like the actual data of Bitcoin in a visual way. So I ended up making this browser. This is on my local computer, but it's basically a blockchain browser in a visual sort of representation, trying to show how all the blocks and transactions fit together, and how you can browse the data really, and then you can go from there and click on the tooltips and find out more about how Bitcoin works. So that's what I'm doing, and that's how I'm interested in Bitcoin. But when I was making this browser, when you download the Bitcoin program and run it, you get the data, but it's hard to query. And so a lot of the ways I wanted to display the Bitcoin data was too difficult to display with the sort of natural native database that Bitcoin uses. So I realized I have to use my own database. And the way I understood how Bitcoin worked, I felt it would make most sense to put the Bitcoin blockchain, like the whole file of data and all the transactions, into a graph database. And that's how I found Neo4j. And I spent about 2 or 3 months figuring out how to do that. And now my website is, the browser is running off Neo4j. So this is like the live version. And this is actual blockchain you can see here. So yeah, that's what I've done. So in this presentation, I'm going to explain how I've managed to get the Bitcoin blockchain, which is basically a big file with all the transactions into a graph database, Neo4j. So as Michael mentioned, I've split this presentation up into 5 parts. The main part is obviously converting the data from the Bitcoin data file into Neo4j, but to be able to explain that properly, I thought it'd be easier to explain it by first explaining basically the basics of Bitcoin works and to explain where the actual data comes from. So when you download this program, where is all this data that you get onto your computer, where's it coming from? And then after that, I want to cover what that data represents, and that data represents a transaction system. So I'll quickly cover how that transaction system looks. And then after that, just quickly go over how all that data is structured in the file. So when we know where the data comes from, what it represents, and what it looks like in the file, then I'll get into the actual import, which is the main part of the presentation. And then we'll cover what the data looks like when it's in Neo4j. Before then, I might cover a few difficulties I had with the import process, but the main part at the end will be just showing you how the data looks in the Neo4j database. Right, so that's the introduction done. I think I'll just crack on with the presentation now with the basics of how Bitcoin works. Right, so basics of Bitcoin. Where does the data come from? So basically, Bitcoin is just a file sharing program. So and it's not. So there's lots of computers all over the world connected together, running the same program. So imagine these circles represent the program, and this file is a Bitcoin blockchain. So it's just a bunch of computers sharing the same file, all connected together. And so if you wanted to join the Bitcoin network, all you have to do is download the Bitcoin program or the client, and then it will connect up to other nodes on the network, and you'll get your copy of the file. So that's all it is. Bitcoin is just a file sharing program that you can join and get a copy of the file. But what's interesting about Bitcoin is that you can add data to this file that's shared across all these computers. So if you wanted to add a line of data to this file, so this here represents a line of data, the way you add it to the file, you don't add it directly to the file on your computer. What happens is you send that data to the computers you're connected to, and they'll pass it on to the computers they're connected to, and until eventually the piece of data will propagate to the entire network. So from there, how does this data actually enter the file? Well, a random computer, or what's called a node on the network, will add the data to the file. This is just randomly chosen. Don't worry about the mechanism for now, but this is how it works. And then they will send the updated copy of the file to the computers they're connected to, and they'll pass it on like so until the updated file has propagated the entire network. So yeah, it's not just one line of data that gets added to the file at a time. You can have lots of different data entering the network, and that will obviously, all those data will make it to each individual node. Let me just move these files down now, that's just to make it look easier to view. So again, I've got lots of data that wants to be added to the file. A random node again will add the latest data they've got to the file, and again, they will share this updated file with the rest of the computers on the network. So that's how Bitcoin works. So what you've got with Bitcoin, it's just basically just a file that's being shared across the world and computers across the world, shared, and anyone can add to it. But what's also important is that even though you can add to it, no one can change what's already in the file. So when you can add to it,
Hey, Greg.
and because it's so secure, you can rely on it as like a ledger, like a bank would use. So if you were to add transactions, now these numbers just represent transactions. If you were to add transactions to this file, you can create a digital currency, which means you don't have to use banks anymore. So using this file that can be added to and can't be changed, if you add transactions to it, you can create a digital currency, and that's what Bitcoin is. So that's the first part done. that's just the basics of how Bitcoin works and how the data gets added to the file and how you can just join the network and get your copy of the same file. Michael, I don't think you hear me, but I did leave pauses here for like questions, but I don't know if I can really take questions, or is it?
So I let me check for questions, but I also have two questions. So one is, if everyone adds to their files locally, individually, how does it handle like conflicts and updates, and when does it know that it has data on each local computer, or can I only add data if I have the most recent computer, or can I always add data at any time? Or is it coordinating?
Yeah, well, the reason I cover the whole is, if you look in here now, it would make sense for this file sharing system. If you want to add data to the file, you would just add it directly to your own file, and then send the updated copies to everyone on the network that way. The reason you...
And if at the same time someone else adds stuff to their file, and or everyone adds stuff to their files,
yeah.
How are these, for instance, ordered, and when they are added, who gives kind of, for instance, the global order of things, or is there an order to additions to the file?
Yeah, this is a very good question. It'll probably take a presentation in itself to explain, but if I better explain it is, when this happens here, when say there was a conflicting transaction in this node, this is called temporary memory here. So when you send new data into the network, it gets held in temporary memory. It doesn't get added straight to the file. So you could have conflicting transactions where someone sends, 1 Bitcoin to someone in the transaction here, and they send, in this transaction here, sends that 1 Bitcoin to a different person. So you have a conflicting transaction. So the reason that the latest transactions get held in temporary memory is so that a random computer on the network will add the transactions that they've got in their temporary memory to the file. And then when they share this with the nodes they're connected to, when this node who has the conflicting transaction receives the new file, they'll actually kick out the conflicting transaction. So this mechanism of a random computer adding the transactions in their memory pool to the file, that mechanism is called mining, and that's what sorts out conflicting transactions and keeps the file secure.
Okay.
It's like,
and
go on.
Itself, you showed it's like a ledger, right? So you say I add like 1 Bitcoin to this wallet, and I remove the Bitcoin from this other wallet. So that means when I want to have the balance for a wallet, I have to go always through the whole chain to compute that, or is there something that kind of accumulates this information somewhere? Yeah,
I mean, basically, on a basic level, if you didn't have your own sort of wallet or database, if you wanted to work out how many Bitcoins you'd own, you'd have to go through the whole file and work out which Bitcoins are on your address. But wallets use their own databases to make that a lot faster and quicker to work out. Because this file is basically
just add the delta on top the last transactions that they have, kind of.
Yeah, so I mean, this file is just a bunch of data. Like, it's not really a database; it's just one big binary file. But wallets, they all use a database. They'll take all this and put it into a MySQL database or something like that, so they can query it a lot faster to find out the balances of particular account numbers, addresses.
Yeah, but on your local computer, do you need the whole blockchain file then, or is it only that parts of the file are on your computer? Because you said it's like at least 100 gig or so for blockchain. Everyone have the whole file on the machine, or how does this work?
You don't have to have the whole file on the machine. If you want to run the original software, yes. Like, so say you joined using the original software, you would download the whole latest copy of the blockchain, which is over 100 gigabytes at the moment, and that also gives you a wallet system to create your own transactions and broadcast them around. But with a wallet, it's not. These are called nodes, but all you need to use Bitcoin really is a wallet. And what that'll do, so for example, in this situation where these bits of new data here are coming into the network, these could just come from a wallet that has a connection to a node. So you can have a Bitcoin wallet that creates this, the data, And all it needs to do is be able to connect to a node and send it into a node, and then it will propagate the whole network. So you can use Bitcoin without having to download the whole file. But if you wanted to join the network and help propagate transactions, then. But I mean, that's more if you're a company, you want to validate your own transactions, I suppose.
Yeah, cool. Okay, please continue then.
Are there any questions I can answer?
I have not seen questions elsewhere yet. No, so you can just continue.
Okay, brilliant. Well, yeah, thank you. I could cover more there, but I think the meat of the presentation is getting the data into Neo4j. So I just wanted to quickly cover where this data is coming from. So you have a file in the computer. Right, so I'll carry on with the next part of the presentation. So then now, so now that we know we've got this file on our computer and it's got transactions in it to create a transaction system, but how does each individual piece of data actually create a system of transactions? So I'm going to cover that now. So let's say this is a line of data that we want to add to the file. This is what a transaction looks like. I don't expect you to understand what this means, but this is just a simple transaction. So how does this work? How does this send money from somewhere to someone else? Well, let's say this is a new transaction, and somewhere in the file already there are 50 bitcoins. Don't worry about where this comes from at the moment. Just trust me that let's say there are 50 bitcoins, existing in the file already, and we want to add a new transaction to the file. Well, the first part, the first step of a transaction is this part here. So this is the first major part of a transaction, and what that does, that references an existing batch of bitcoins in the file. So this code here is just code saying I want to use or spend this existing batch of bitcoins. So that's the first part of the transaction, or the first major part of the transaction. The second major part is where you create new batches of bitcoins from those existing batches of bitcoins. So in this transaction, it creates two new batches of bitcoins from the one it referenced, like so. So obviously the first one had 50 bitcoins, and that's turned that into a new batch of 40 and a new batch of 10. Now the question is, okay, we've just taken some numbers and turned them into new, blocks of numbers. How do they belong to anyone? Well, if you go back to the first one, inside this first one, where we created the new batch of bitcoins, the first part tells you how many, and the second part is actually what's called a lock. And that lock makes it so that if you wanted to spend these bitcoins in a future transaction, you have to satisfy this lock. And what that means is that, well, a common type of lock is to say that this batch of bitcoins belongs to a specific address, which is like an account number. And so if you wanted to spend these bitcoins in a future transaction, you would have to prove that you are the owner of this address, which is like an account number. So each of these new batches of bitcoins will have their own unique lock on them. So one could be sent to your friend and one to your mum. These will just be account numbers that the bitcoins are locked to. So carrying on from there, let's clean that up. I've just taken away just to clean up the presentation, but just remember there are locks on them. Okay, let's say you've got a new transaction coming in. This one's a bit longer, but again, it's going to have this exact same structure. So let's run through it and see what happens. Again, the first major part of the transaction, it references an existing transaction, batch of bitcoins. Now these are called outputs. So let's say this is referencing an existing output that it wants to spend in a new transaction. So, but remember, this one has a lock on it. So to be able to spend this, we need to prove that we own, or we have the sort of password for the address, really. Those aren't the technical terms, but I just want to try and have it make sense as clearly as possible. Okay, so inside this referencing part of the code, there's a little unlocking piece of code, and this satisfies the lock. So now that we've referenced it, we give the unlocking code so that we can use this batch of Bitcoins and spend them and create new Bitcoins from them. So again, now that we satisfy the lock, we create the new batches of Bitcoin from this existing output. So again, all a transaction is, it references an existing batch of Bitcoins, unlocks them, and then creates new Bitcoins from them. And again, these will be given their own locks. So, in this sequence of transactions, it started with one person, could be sent to someone else, and then to someone else again. So all this data resides inside the file, and everyone has a copy of this file. So even though you feel like Bitcoins belong to you, they're actually on every single file of everyone running the Bitcoin program. But the reason they belong to you is because no one can spend them, because they don't have the password to be able to unlock them. So that's how Bitcoins belong to you and how they get spent and sent. Again, so let's say another transaction comes through, and this takes an existing batch again and creates more outputs from them. You're not restricted to one or two. You can make as many outputs as you want. Similarly, with another transaction, you're not restricted to using one batch of Bitcoins. If you want to say, if you owned all these and you wanted to send more than 40 to someone, you could reference more than one existing output. And so in this one, it's taken 3 in and it's created 1 new one. Or again, you're not restricted to one output. That could be multiple outputs. So this is the basics of how the transaction system works, just referencing existing Bitcoins and creating new ones from them. And so after a large series of transactions, you end up with a transaction system that looks something like this. So again, it's like a simple beginnings, but with lots and lots of transactions building on top of each other, it gets more and more complex like this. But it all follows the same pattern and structure. And it's all in one file. So just all the data in one file, and it represents this kind of structure. And that's how the Bitcoin transactions work. Right, that's the end of the second part. Is there any questions I can answer there?
Yeah, so I have, so I think there are no other questions, but I have 2 questions. So one is, you said it starts all with a fixed set of Bitcoins in this case, and then they are kind of split and 2 different accounts and merged together and so on. Is there also a means of adding like new Bitcoins to the transaction network, or is it always based on the?
Yeah. Imagine these original Bitcoins, they came from, like I haven't covered this earlier in the basics, but these come from when a new block of transactions gets added to the file, they will release new Bitcoins that can be spent. So imagine these were released as part of a block. It might make a bit more sense in the upcoming sections, because I'll cover that a little bit more. But does that sort of help? But so we don't have one set of Bitcoins. There are more and more coming every day being released.
Okay, and that's kind of the mining bit, I think, right? Or,
yeah, so these, imagine from the mining, this is the origin of new Bitcoins, and transactions that we make, these are just spending them.
Okay, cool. With the accounts, is it so that you usually have like one account, or can you also do like multiple accounts and then kind of move and split between them? Or is there like a hierarchy of accounts that you can say, okay, these accounts are actually, or these kind of addresses are actually connected in some way? Or is it always like each address stands for its own or on its own, so that there's no kind of obvious connection between addresses except for the transaction flow, actually?
Yeah, basically. On a basic level, the most common level, each individual account, which is called an address, is unique, and it actually comes from generating your own random number. So to use Bitcoin, all you need is what's called an address and a private key. The address is like the account number, and the private key is like the password that proves that you own the address. And you start off with a private key, which is literally just a very big random number, and then you create your own address from that. So then you send your address out that people can send Bitcoins to. So basically, yeah, every single address is gone.
Cool. Thank you. Please continue then.
Okay, thank you. Right. Nearly at the good part now, where we go cover the importing the data into Neo4j. But just before cover that, I wanted to show you what the structure of the data looks like in the file. It's not too dissimilar from it all being one big long series of transactions like I showed you before, like just this kind of structure repeated over and over again. But as I mentioned before, transactions aren't added to the file individually, like one at a time. What happens is transactions get added in containers or batches, which are called blocks. So you have blocks of transactions being added to the file every 10 minutes. So what that means is, along with the transaction data, you do have a little bit of extra data for the sort of wrappers or containers to describe the block transactions, really. So I'll just cover what that looks like. So just for good measure, right? So this is a block of transactions. We have all that transaction data, like we showed you before, all the same sort of structure. But in addition to these transactions, at the very top of the block, we have what's called a block header, which is basically just a little bit of metadata to describe the block. It's got things like the time and the version number in there. But this just describes the block, really. Then in between the block header and the transactions, you have a little few bytes to tell you the transaction count. This just helps you with parsing through the block, so you know how many transactions you need to read through. And similarly, just before the block, you have the block size, which tells you the size of the block in kilobytes. Again, helps with parsing. And you have a little few bytes called the magic bytes, which is just this special specific set of bytes that stays the same, and it just acts like a marker, so you know where a block starts. So as you're reading through the file, you're looking for these magic bytes to signify the start of each individual block. So, but again, these are just extra bits of data to help you with parsing. The real meat and useful data we're going to be looking at is this block header that describes the block and each individual transaction. So this structure for each block just repeats itself throughout the file. So once you know the structure of one, you know the structure of all of them, and you can read through the file. So yeah, where is this file located on the computer? Well, I'm running Linux, and it's located in my home folder in the .bitcoin folder. Then if you go into the blocks folder, that'll show you the this one big file, the blockchain's called. But it's not actually one big file, it's actually split into multiple smaller files, like so. So again, instead of being one big 100 gigabyte file, it's split into multiple smaller ones. And the way that works is when you download the Bitcoin program and you start downloading your copy of the blockchain for the first time, you'll start filling up your first file with the name block 00000.dat. And then when you fill out that, when that hits 134 megabytes, that's just the limit for each individual file. You'll go on to block 00001.dat and then fill that up for the next one, and so on until you've ran through all of the individual files. It says 710 there. I think there's just over 900 at the moment. And also the sum of all these individual files for the blockchain is 108 gigabytes. So that's just the structure of the file and where it's located. Is there any questions about that one?
No, it's all straightforward.
Okay, thank you. Right.
Well explained. Thanks.
Thank you. Right. Hang on 2 seconds, I'm going to consider tea. Right. Now then, right. We've covered the basics of where the data comes from. Now we know what the data is representing, and now we know how the data is structured in the file. We can start importing it into Neo4j. So in this section, this is the longest section, but yeah, this is the main part. Right, so I'll just get started with it. Right, okay, going back, here's all so my program that I've written, it reads through these block.dat files, because this is the blockchain. So basically my program reads through each of these files and adds them to the Neo4j database as it goes. So let's say this is a typical block inside one of the files. This is the first one. This is the first block, for example. And this here represents the canvas, which is my Neo4j graph. I'm not going to be showing any cipher queries. I thought it'd be easier just to illustrate how the graph is built with diagrams. So on this left-hand side, I'm going to be running through a block and showing you how that populates the graph database. So my program starts running through, hits the first block, and then it hits the first block header. So now we've got some data we can add to the database. So now that we've hit a block, I create a block node with the label block. And if you remember, a block has a block header, which is just a bunch of metadata. So I add each of these bits of metadata as properties on the block node. So you have the hash, first of all, which is like an ID number for the block. So that's the first thing I set, but I also give that an index so that you can retrieve the block more quickly, because these are always unique. So I give it an index. And then after that, I run through the block header, adding each individual part of the block header as properties onto the block. So that there we have a block node. What I should mention as well is each block, it creates or makes available new Bitcoins that can be spent. So the way I show that in the graph is I create a node called a Coinbase node, because that's what the term is for new Bitcoins that have been created. And this is rated coming off of the block node. And I give that the relationship, the label Coinbase. It's probably a bit redundant, but just need to make sense at the time. So there we have a block. The Coinbase also has a value, because a block gives off a set amount of Bitcoins. And I put the amount of Bitcoins as a property called value. And this here represents 50 Bitcoins. It obviously looks like a lot more than 50 Bitcoins, but this is just 50 represented in the lowest denomination of Bitcoins. It's like saying, $1 is 100 cents. This here is 50 Bitcoins. So let me just move that onto there, just for make the diagram easier to read. So here we have the first part of the import done for a block. We create a block, put the block header as properties on the block node, and create a Coinbase node coming off the block. Right, so now we've done the block, we can move on to the transactions. So hit the first transaction, and so I create a transaction node. First thing I do is I give it a property called a TXID, which is very similar to the hash from earlier, which is, it stands for transaction ID. And again, that's just an ID number for the transaction. And I also give this an index so you can find it more quickly later on. Either side include. So this transaction is included in this block. Right. Important thing about Bitcoin is the very first transaction every block actually spends the newly created Bitcoins, so the Coinbase node. So in this reference part of the transaction, it just takes in the Coinbase. So I take that into the transaction so that I can create new outputs from it. So with the reference part, I just relate the existing Bitcoins as an input into the transaction node, and I give that a label in. And then the second part, it creates new Bitcoins, and these are called outputs. So I give the label output with the relationship label out. And I also give these some properties. Every output has two major properties, and that is the value, how many Bitcoins, your new Bitcoin, not new Bitcoins, but what the size of the new batch you're creating, and also the lock. Now this is called a script pub key. That's just a technical term for it, but again, that's just the lock. So every new output you create has a size, like a value, and a lock on it. So this here is a very typical and simple first block and the first transaction in the block. Again, you just take the Bitcoins in and create new Bitcoins from them. Right, so move that to the side, move on to the next transaction. Again, create a transaction node and relate it to the block. I've obviously put the properties on here, but I'm just showing the structure of how the graph is built now. So relate it to the block, isn't it? Because it's included in the block, and then references an existing batch of Bitcoins called an existing output. And if you remember, we've got to be able to satisfy this lock to be able to spend it. So inside this referencing part of the code is the unlock-in code. So I put that as a relationship from the output onto the transaction node. So it just seemed to make sense to put on a relationship. So that's why I put the unlocking code. And that's called a script sig. But again, that's just a technical term using Bitcoin, but that's the unlocking code. So here we have a transaction. The lock is put on the output node, and the unlocking code is put on the relationship that takes for the transaction that's trying to spend it. And again, move on to creating the new Bitcoin, the new batches of Bitcoins. There's 40 and there's 10. So again, this portion of transaction data here has created this section of the graph. So this is the basic structure really of how I take what I showed you earlier and recreate it in a graph, taking existing Bitcoins into a transaction node and creating new ones from them. Now, lastly, what I do is, if you remember, each lock, they can lock Bitcoins to a specific address, which is like an account number. So if a batch of Bitcoins, an output, is actually locked to an address, I will create an address node for it, and with the label locked, and put that address inside the address node. So for each of these, I'll give the address an index as well, so you can find it fast in the database later. So again, each node, each output could be locked to an address, and if a particular output is locked to an existing address node, then I'll connect it to the same address, so these addresses aren't repeated. And this makes it easier for later on when you want to query the database and see if there are any connections between Bitcoins that belong to address. You want to see if any addresses are connected together. So this here is basically, if you understood everything I just said, then this structure just repeats itself throughout the graph. So you just have a new transaction, take Bitcoins in, create new Bitcoin nodes, output nodes, and connect them and lock them to addresses. And this structure repeats itself throughout the graph. Take them away for a minute, make it simpler. I'll do one more transaction just for good measure. Again, let's say I've included this into a block, but I'm not going to in this diagram, just to make it simpler and cleaner. Again, same thing, it takes existing Bitcoins in, but just to mention, you're not restricted to only being able to spend the outputs that have already been created in the same block. So say, for example, we had already added a block of transactions to the graph. So here we just added an existing block of transactions, and they're already in the graph. You can reference existing outputs from earlier blocks, like so. Just thought that was worth mentioning. And again, you create new new outputs from the sum of the outputs you've referenced. So this is the transaction system. So again, just move that down there. And this, say you've run through another block now, we just built upon the graph. So same as before, like I keep repeating, just referencing existing outputs and creating new ones from them. I've taken the blocks out here just to keep the diagram clean, but just imagine that each of these individual transaction nodes are connected to their respective blocks. I think finally now, each of these, if you remember, well, just bring the blocks back in. Each block creates new Bitcoins, and each of these transaction nodes are connected to their respective blocks. Each block is also connected to the one before it, and it's called I give that the label chain because they're chained together because they build on top of the previous one. So when I encounter a new block, I'll connect it to the block that it's building upon, like so. And this is why the whole database is called the blockchain. So there we have a 2D simplified overview of what the entire structure of the database looks like. Obviously, it's not all connected together because I'll have lines everywhere, but this is, here we have the blocks, creating new transactions, adding these new transactions, building the graph out. Each block creates new Bitcoins, and they get spent by those transactions. And this goes on and on with every new block. Now, I haven't added all the pictures here on the diagram, but just imagine that this graph is getting bigger and bigger with every new series of blocks. And so as my program is running through the file, it's adding new blocks, like so, building the graph out. The graph is getting longer and taller until eventually, if you let the program run long enough, it will run through every single block.dat file and every block, and it will have all the blocks added to the database. There's currently, well, there's over 470,000 now, but it was when I made this presentation, and the entire Neo4j database will be roughly 650 gigabytes. So it's pretty much 6 times the size of the native binary data that isn't really a database of the Bitcoin blockchain. And that's the whole import, really. That's most of it. Yeah, I think that's everything. So, any questions?
Cool. Is there any limit to how many blocks or how many batches of coins a transaction can use and create, or is it arbitrary? Can it be arbitrarily large? So can one transaction create like 1 million tiny Bitcoins, or like consume 1 million of those?
Yeah, basically. So every new transaction, it could reference, thousands of existing outputs, and it could also create thousands of new outputs. The limiting factor really is that every individual block has a maximum size of 1 megabyte, and so each obviously transaction is data, and the more outputs you're referencing and creating, the bigger the data will become. And so the limiting factor is like 1 megabyte. So you could create a transaction spending thousands and thousands of existing outputs, but there is a limiting factor.
Yeah. Does it make transactions more expensive if you create more outputs or consume more inputs? Or
yeah, exactly. Yeah. So the cost of a transaction really depends on how big the data is you want to add to the file, because the disk space is the resource you're using. So when you create a transaction, it doesn't matter how many Bitcoins you're spending. If you sent 1,000 Bitcoins, but all you were doing was referencing one output and creating one new output, that would be cheaper than if you made a very, very small transaction where you referenced loads of existing outputs and created lots of new outputs also.
And another question, the initial coin base for each block, where does it, do you need it? Why aren't these just, you know, as any other places as well?
So you can say that again, sorry.
Initial set of the coin base for the block.
Yeah, is a question, where does it come from? So I missed the question, I think.
So the question is where the Coinbase Bitcoins come from that each block starts with.
Yeah.
Or could it be also zero, that there's actually like no new Bitcoins from a block, or does this come down from mining, kind of from creating a block? This also kind of creates a new.
What happens is the first transaction, like here, has some freedom, and it has the freedom to make a transaction that sends bitcoins, send bitcoins to an address, and those bitcoins don't necessarily have to exist yet. So it gives you the freedom to basically create new bitcoins, like so. So this Coinbase, I mean, it's not actually anywhere in the data, but the protocol, the way Bitcoin works, it allows you to send a set amount of Bitcoins with this first transaction to your own address. You can, that makes sense.
Okay, cool. Other questions, so please continue with the next section.
Okay, well, that's the whole import process. What I'm going to go on to now is just show you quickly what the script looks like when it's running, because I've actually put this code on GitHub. So if you were to get it running, I'll just quickly show. What it looks like. Okay, so if you were to get this code running, here's just an example of the import process as it's working. Let me reduce the size of my font so it makes a bit more sense. Okay, so now I'm script, and here it's each individual one of these lines is a transaction. This part here, this is the block ID or the block hash. These are each individual transaction. This is the size of each one. This is the number of nodes it's creating. I find that interesting because with Neo4j, if you're referencing a lot of existing nodes, then it'll take a lot longer to import. And this is the time for each individual transaction. Now, this is just running on my local laptop, which is a ThinkPad X220, and hasn't got a lot of RAM. It's got like 4 gigs of RAM. Not a very fast processor, but it has got an SSD. So this could be a lot faster, but this just highlights how just the script in action. Because it takes so long to run, I've set it so that you can cancel it and then restart it. So if your computer switched off, the program will remember where you left off and it'll restart again. So again, if you just cancel it and restart it, it'll pick up from where you left off. So that's the script in action if you get it running. What I will mention as well is that when I run this on my server to actually import the blockchain myself, I ran this on different sections of the blockchain. So for example, I might have 8 of these scripts running at the same time and run one on the first, say, 100 files and the next one on the next 100 files and so on. And that seems to speed up quite a bit.
Parallel, more or less, right? On each
that was just, yeah, I could have probably done it programmatically a lot better, but that just seemed the simplest and easiest way to do it.
Yeah.
So that's a script running. I think now really the most interesting thing I could do is show you what the data looks like inside the Neo4j browser. So, yeah. Here are some queries I've already made to show the data. This one here is going to show us a transaction with all of the inputs and outputs, and also the block it's connected to, like so. So here we have this part here is the transaction. These are the outputs, and these are the inputs, and these are the addresses that the outputs have been locked to. So that is like how the structure for every transaction looks throughout the database. So for example, say this output was locked to the same address as this one, then this would look like that, really. But so anyway, what's interesting about Bitcoin is you can follow the path of transactions. So if you double click on this, there's a transaction here, and you can see the outputs that this one has created. And so for every transaction, you can keep following the transactions and the outputs that is taken in and created, on and on and on. So every single transaction in Bitcoin is connected together, and you can follow that path of transactions. And you can also see, double click on this, you can see all of the transactions that are included in one block. So here all the transactions include this block. This is the Coinbase being spent by this transaction. Here's the block that's connected to below it, see all the transactions there, and so on and so on. So it's all connected together. I think this illustrates it quite well at the moment. I think I've covered everything. See if I've got any other queries, but these are all sort of pre-made queries where I can just find a specific block and see all the transactions connected to it. Here we can see a series of blocks in the chain. Here we can see all of the outputs connected to an address. So if you had an address, you could find all the outputs that have been locked to this address, and this way you can find out the balance of your address by summing all of the outputs connected to your address. But you obviously have to sum the ones that hadn't been spent yet. So this one hadn't been spent. That's like an output. Yeah, so you'd have to. That shouldn't be there. So you can query Bitcoin and get all these interesting things like the flow of transactions, all the blocks, the balance of addresses, and probably most interesting is that you can enter two addresses, and like here you could enter two addresses to see whether they're connected. So say someone's storing Bitcoins and you know that what their address is, and for some reason you suspect they sent it to an address that also belongs to them, but identifies them as who they are. You could run a query to see whether two addresses have been connected together. So with this particular query here, I've entered two addresses, and it's showing me that the transaction flow for how those two addresses connected. So you can see from this one that it sent the Bitcoins to a different address, and then another address send them to the address that you want to see if they're connected by. So yeah, you could use, so by putting all of the transactions into Neo4j, you can create a query where you can follow the transaction flow from any 2 points in the database, and it runs pretty fast. Yeah, that's pretty quick. I think I've run this query before, but with that structure I showed you earlier, you can see if any two transactions are connected together. You could see if any two specific outputs are connected together, or you could see if any two addresses connected together. So if you have to do fraud analysis, nothing's hidden using this structure. Yeah, I think that's the browser done. I've got one extra small set of slides to show some of the complexities or some difficulties I ran into when I was doing the import process. Would it be okay to run through them quickly?
I have just 2 or 3 comments to the querying. So I really like this, and it's kind of you can import the whole blockchain into one Neo4j database and then start querying it.
Yeah.
There are some really cool things that you can do. For instance, if you know an address, for instance, someone receives payments, then it's quite transparent how much money they made, for instance, on this address, right? Or if you have someone who is kind of ransoming data on other computers and they put in their address to pay Bitcoin, so actually you see kind of how much they actually made and who's been, or kind of which addresses have been paying them, and then you can trace the money where it goes from there.
Yeah, and then like with the recent ransom attack, they requested Bitcoins, and you could watch the new payments coming in, and you could see, and now that you know they're Bitcoin.
Yeah. We're lost. No. Hey, sorry, I lost you for.
Okay, yeah.
So this is really cool, and I'd love if we can make this available somehow. So let's chat about this later. That would be really cool, so that people can query the data themselves. That would be.
Yeah, I've got some very simple available at the moment. But do you mind if I cover the 1 or 2 difficulties first, and then I'll cover
please go ahead.
Okay, just to round this off, it wasn't 100% easy to import the data into Neo4j. One of the, aside from just learning Cypher and just figuring out how to do it, one of the biggest difficulties was when you download the Bitcoin program and you connect to other nodes and they send you blocks so you can build your own blockchain, they basically send you blocks as fast as they can. So they don't actually send you the blocks in order. So what happens is you have all the blocks in your files, but your files are not in, the blocks not in order. So what that means is a common thing I like to do as I'm running through, or it's very useful, as you're running through each block, you want to give each block a height. So the first block is obviously block 0, and then the next block you run into, that'll be connected to the initial block. And because it's connected to that block, you can figure out from that initial block that the next block's height is 1. But eventually, you're going to run into a block that tries to build on a block that you haven't read yet, so you can't set a height for it. So the way I got around that was just to keep track of each block that doesn't have a height. I store that in Redis, which is like a just fast, quick memory stored in RAM. And then I keep track of each one. And so eventually I will run into a block that connects to a block that does have a height. So when that happens, I grab the chain above it, and then I update each of those blocks of their heights with the height, because I can calculate it then. So you just basically with Neo4j, when this happens, I can get this path of nodes and I can go through each one and update them. So that's how I get around the whole block height problem. Another problem with the block being out of order is what will happen is, as you add in transactions for each block, you'll find that one of those or a number of those transactions will be trying to reference outputs that don't exist in the database yet. So these will be trying to reference a specific output that has a specific ID. So what I'll do is, in this instance, I will give this output to just a placeholder. So I won't be able to have the data to fill it in yet, but I'll give it a placeholder with a specific ID. And then eventually, when I do come to a block that holds the transaction that created this, like so, this transaction, finally I've got to it and I've added the transaction. Now it's creating this node that we wanted earlier. So I just merge onto it and I update the properties like so. So those are the two things that the figure out and work around was the blocks being out of order. But with Neo4j, it's possible to, well, it allows you to work around this and fix the problem. Okay, so that's the major difficulties. I think, is there any questions there, Michael, or should I carry on to show you the interface I've got?
I think because we are probably short on time, it's probably best to carry on with the interface.
Yeah, right. So this is my website. It's called Limit Bitcoin. This is the browser, and this is running on Neo4j. It's very simple, but it's a very simple interface. So you can query it by finding any blocks you want. Go to the top again. These are all the blocks. You can browse through the blockchain. Again, it's just simple PHP really. And here's a block. Here are all the transactions in the block. And you can, there's a transaction. Again, these are the inputs and these are the outputs it created. I haven't got the connections there. It's a bit tricky with CSS, but just imagine they're there. And from here, you can go through the transactions. So here we are, we're going through the flow of transactions and go out to the block again. So like so this shows you all the data in Bitcoin on this website, inside the Neo4j. So this is if you wanted, there's a transaction, just enter the transaction ID and it'll find it for you. Or if you had a particular block number, just enter the block ID and it'll find the block for you and all the transactions in it. And again, this is all running off Neo4j and it's quite fast. I've also got, let's see if this works, I haven't tested this yet. Okay, well, you can, if you have an address you want to check the balance of, here we have the address and these are all the outputs connected to this address. This has an output connected to it, but it's been spent. So that is the output. It's already been spent in the transaction, so you can't use it anymore. So going back there. So, you know, you can query, you can use this website to query the database for any block or transaction or address. I suppose what would be most interesting for querying this database is to find connections between two different addresses. So I have got a very, very simple tool to do this. So let's take this address here. Let me create a new tab. My tool, it's called the path tool. So let's enter that address there. And this one here. So here's the tool. You can enter two different addresses. So say you had, this was your address or some address that you know install your Bitcoins and you know this other address, you can see if their two addresses are connected. So this here, again, very, very simple. It just shows you the sequence of transactions and you can figure out the times, how long it took and how much has gone through. I mean, it's probably not great for analysis, but it's just a very simple tool I've made just so you can query the database to see if two different addresses are connected. Yeah, I think it could be a lot better over time, but this is where I am so far.
Really cool, really impressive. So I think that's really cool work, and I'm thinking of all the possibilities of what you can do with this, also to kind of, you know, have people, for instance, things that happen in a in a blockchain, or like exhibit their payments, for instance, for transparency. reason. So someone could say, I'm receiving like donations and I want to show like transparently how much I got. Or if a startup does an ICO or something like that, you can actually see on the blockchain how much they got for the ICO and so this would
exactly.
payments.
Yeah,
and then of course you can also find all the criminal activities. So if you know the addresses of people that did something, the ransom thing or that, then you can actually see how much money they made and where it came from and where did it go to and stuff like that. So which is really, I think, pretty cool.
Yeah, exactly.
And you could, also have something like almost like an account management for your Bitcoin, right? So you can just put in your address or addresses, and then it shows you all the transactions for your addresses and as a ledger for this. So
it makes money more programmable, I suppose. Yeah, makes it just easier to follow. Nothing's hidden, and you can program it and you can just use it more freely.
Really cool. So just check for if there are any more questions, but it doesn't seem so, and I think we're also out of time. So thanks so much, Greg, for showing this. This was really, really cool, and I'm sure there will be lots of interest of people watching the video later as well. And I would love to talk to you about later about kind of making things like that available to people to query freely and so on. But let's take this for later. Cool. Thanks so much for your time, and I'll stop the public broadcast now. Oh, sorry. No, I don't. Sorry, I just almost totally forgot something. Let me just quickly share my screen. Come on. There you go. So thanks a lot, everyone, for watching. And I really just quickly want to share two things with you. So first of all, as you might know, Graph Connect New York is in October. And currently, up until the end of July, we have a $199 early bird ticket for that. And you can get 20% off that with Community20 as a discount code. And if you kind of pass the Neo4j certification, there's even a discount code which gives you 50% off. So make sure to get certified, and then you get 50% off the conference ticket, which is really cool. We also have some really cool upcoming next online meetups. So the next ones are Dawn next week, speaking about natural language understanding with Python Neo4j. Then my colleague Nigel will talk about the Neo4j drivers and the existing drivers and the plans for the future. And Nick will, on July 27th, talk about or demonstrate how you would represent and import corporate networks into the graph, and then what you can do with that. And with that, of course, this has been recorded, so it's all available then on the YouTube channel. And thanks a lot, everyone, for joining us. And good evening, and see you